Hi, y'all. It's Mother Nature. No, it's really Miss Zachary. I'm a high school biology teacher at Sherman High School, and I'm teaching the concept of protein synthesis today. I'm trying to prepare my students for their unit test over DNA and protein synthesis, as well as I'm also preparing them for the end of course test that we have to take here in Texas. This video is made for my students, but anyone who needs a little knowledge about protein synthesis is welcome to watch this video to review concepts, basic concepts of protein synthesis. Alright, so I'm going to tell you a story. This story is all about protein synthesis. So what do we already know? We know that DNA is too big of a molecule to make it out of the nucleus. Remember that DNA is double-sided. It's a double helix. It has two sides. And it cannot go through, it does not fit through these nuclear pores. DNA has all of the instructions for how to build a protein. So what does DNA have to do? It wants to send a message to the ribosome, because the ribosome, as you recall from our unit on the cell, makes proteins. So what does the DNA do? The first thing it does is it splits like this, staying in the nucleus, and what happens next? That's right. Messenger RNA comes in, and using the base pairing rule, A with U, G with C, it comes in and it lines up with the correct DNA base. Okay, I'm going to take a little time out here because I've got to remind you of something. Remember that this is DNA. How do you know it's DNA and not RNA? That's right. It's because it has thymine in it, or T's, if you cannot remember the word thymine. It has T's in it. And DNA has thymine in it, whereas RNA never has thymine in it. Well, how do you know this is RNA? That's right. You know that it's RNA because RNA has the nitrogen base uracil, or use if you can't say that word. RNA never has thymine in it. It will have uracil in it. DNA never has uracil in it. It will have thymine in it. So the T is replaced in RNA by a U. So thymine is replaced by uracil. All right, so back to our story. So DNA is too big to come out of the nucleus. DNA is grounded to its room. Its room is the nucleus. It wants to send a text message out to the ribosome with the instructions on how to build a protein. So what does it do? The DNA splits, and using Chargaff's base pairing rules for DNA and RNA, messenger RNA comes in and takes a message from DNA. This process is called transcription. In the word transcription, do you hear the base word scribe? Scribe, recall, means to write. All right, so what has happened here is DNA has given the message over to messenger RNA in the process of transcription. Once it's gotten the message, T with A with U, C with G, C with G, C with G, G with C, T with A, C with G, A with U, C with G, A with U, G with C, A with U, T with A, T with A. Once it has taken the message, what it does is it zips back up, DNA being it, DNA zips back up. RNA, which is the right size and can fit through the pores, comes out of the nucleus and goes and finds one of the many ribosomes. Remember that there are a lot of ribosomes, and when we drew the cell way back in our cell unit, we drew them as dots, okay? Well, this is a little closer to what a ribosome looks like if you were to take a electron microscope and actually zoom in on a ribosome. All right, so we're going back to here. So this has the text message with the instructions on how to build the protein. It comes out into the cytoplasm, finds a ribosome, and it lands on the ribosome. Then 3 bases at a time. Remember that 3 bases are a codon, 3 consecutive bases. First one is A, U, G. All right, so now you've got to take out your codon chart and read the codon chart. Okay, so first position is A, or first letter is A. Second position is U, or second letter is U. Third position or third letter is